Hello everybody, we're going to talk about the Doppler effect. The team is conformed by Francisco Javier Flores Ruiz, Edson Alberto González Amatón, Juana Montserrat Benítez Rivera, and me, Cristian Eduardo Santillán Rangel. Let's start.
Hello everyone, my name is Mons Benitez and today we're talking about the Doppler effect. Let's well, who discovered this effect? It was discovered by Christian Johann Doppler, who described this effect as an increase or decrease in the starlight that depends on the relative motion of the star. In another words, how can I describe this? The Doppler effect tells you about change in frequency when there is some movement between the source and the observer. Well, as we know, all the source generate waves like this in the same frequency that these waves are concentric and span around this area. And what is happened when, for example, the source moves to the observer like this? Well, the do is that the frequency change and be that these waves are no more concentric, and this means that when the source are close to the observer, the frequency increase between this wave. But for the another wave, if the source is go away for the observer, the frequency decrease. Well, my next classmate explain another part.
Hi, I'm Paco and I'm going to explain the formulas that allow us to find the frequency to the Doppler effect. So we have two frequencies, the source frequency and the observer frequency. To know the frequency of the observer, we have four cases. For each one, we have to use the formula according to the general formula. This is the general formula. We have the observer frequency that is equal to source frequency by speed of the sound plus minus observer velocity over speed of the sound plus minus the speed of the sources. And the first case is when the observer goes to the sources. The frequency that the observer increase. So the formula is observer frequency is equal to source frequency by speed of the sound plus velocity of the observer over speed of the sound. The second case, this is the first. The second case is when the observer moves away of the sources and the frequency is decreased. So the observer frequency is equal the source frequency by speed of the sounds minus velocity of the observer over speed of the sounds. The velocity of the source is equal to 0 because it doesn't move. The third case is when the source travels to the observer. We have the source travel to the observer. So the frequency is increased and the formula is observer frequency is equal source frequency by the speed of the sound minus the source velocity. All of this is divided for the speed of the sound. Sorry. And the observer, the velocity is equal to 0, so it's not considered here. The fourth case is when the source moves away to the observer and the frequency is decreased, and the observer frequency is equal to source frequency by the speed of the sound over the speed of the sound plus source velocity. And these are the four cases we have, and that's it.
Hello everyone, my name is Edson Alberto and today we are going to see how to figure out a Doppler effect problem. The problem is the following. An ambulance travels north 15 meters per second. Its theta siren has a frequency of 600 Hz. A car traveled about 20 meters per second towards the ambulance. Calculate the observer frequency the car listens before passing the ambulance. So we're going to write down the following values. The frequency of the source is 600 Hz. The velocity of the source is 10 meters per second, and the velocity of the observer is 20 meters per second, and the speed of the sound, velocity of the sound in the medium, yeah, you already know, is air. So, the next step is identify our values in the formula. We have our values. We're going to write down our formula, which is frequency of the observer is equal frequency of the source times the velocity of the sound in the medium plus or minus the velocity of our observer over the velocity of the sound in the medium again. So the medium plus minus the velocity of our source. We're going to substitute our values in this formula, and we are going to take one sign if the pencil is away or if it's going towards. In this case, as you know, in the problem says that the ambulance is going towards the ambulance. We're going to, this is the ambulance. Just imagination. And this is the car. This is our car. And the car is going towards. So the velocity of our source and the velocity of our observer. As you already know, if the source is going towards to the observed, this sign is going to be minus. And if the observer is going towards to the source, this is going to be plus, right? So the frequency of our observer is equal to the frequency of the source, which is 600 Hertz times the velocity of the sound in the medium, 343 meters per second, plus the velocity of our observer, which is 20 meters per second. And again, this is the velocity minus the velocity of our source, which is 15 meters per second. And we, as you already know, we have everything good. We are going to have the result, which is 24 years. If you have this value, you are totally okay. So thank you. Follow me for the next problem, and have a nice day.